until it says 1:01 on my clock since we're still getting some people joining. Okay, well, welcome everyone. This is Alan Taub. I am the director of the University of Michigan Electric Vehicle Center. And actually, at the end of this month, we will be celebrating our third year of our 5-year initial contract with the state. I hope everybody had a great summer. We've been running our Surge webinars monthly, but decided to let people take vacation. And so we are starting our new series today with Dr. Chris Borroni-Bird. Chris and I go back over 20 years now. We worked together at General Motors, and I have to say, he is a relatively unique individual and able to do design and engineering, but more importantly, on ideas that are breaking the mold. And we've ran a number of those projects in GM. And since leaving GM, he's been involved with Waymo. He's been a research scientist at the MIT Media Lab, was with Qualcomm, and is now has his own consulting business, a Afreecar, if I'm pronouncing that correctly. But I'm really looking forward to see what Chris has to say as we move on to the new generation of mobility and vehicles and how both their usage and the architecture will change. And with that, Chris, I'm going to turn it over to you. By the way, please hold your questions until the end. You can put them into chat. And at the end of his webinar, Jamie Ratcliffe, our communications director, will manage the questions. Thank you, Chris.
Thank you. Can everybody see my slides?
Not yet.
Okay.
We see your email box.
You see my slides now?
We see your email box.
Oh.
Still the email box.
Oh dear.
It worked in rehearsal.
Jamie, do you have them loaded just in case?
I do. Chris, you want to go to mine?
Yes, let's do that. I apologize for that. Good afternoon. It's a pleasure to be here, and I'm really happy to be able to present these slides to this seminar series. I'm going to be talking about sustainable and affordable mobility for everybody. So normally we think of the developed world and the developing world. As you may know, there's about 8.5 billion people on this planet. About half of them live in South and East Asia. And oh, now I'm seeing the cover slide. Oh. There's about 1.5 billion vehicles actually on the road and about 90 million automobiles sold per year. So, oh, I can't animate now, can I? Okay, so think about in the developed world, there are poor people in the developed world and there are rich people in the developing world. So it's perhaps a little bit more logical to think about new car buyers. And in this case, how can we make mobility more sustainable?
Click.
For everybody else, which is roughly 90% of the world's population, the challenge is how can we make mobility more affordable? So these are the two challenges that I'm setting out to try and answer. And that will be the thesis of my presentation. So I'll talk about the current status of the auto industry briefly, and then I'll talk about what I think are some future problems that we can see coming down the road. And then I will postulate a new approach which talks about tighter integration between the automotive and the mobility sectors, rethinking vehicle design for right sizing of vehicles, and then rethinking how vehicles are manufactured, which involves city policy as well. So talking about the current status of the automobile. Vehicles, as you may know, are getting bigger and bigger with each generation. This is a slide showing roughly 40 years worth of 7 generations of the Volkswagen Golf. And if you look at it more recently, in the last 20 years, vehicles have typically grown about a couple of inches in width per year, or per every few years, I should say. So in the course of 20 years, they've grown by 100 millimeters, which is about 4 inches. So this is a significant increase in the width of the vehicle. And it goes with the vehicles getting bigger in all dimensions, not just the width. So the vehicles aren't just getting more larger in size, they're also becoming heavier and they're becoming more powerful. So this is data from the EPA, and it shows that although real world fuel economy has risen over the last 20 years, it would have risen a lot more if the horsepower to weight ratio of the vehicles had stayed constant, and if the vehicle mix had stayed roughly the way it was, which was car dominant. So over the last 20 years, more and more people are driving SUVs and pickup trucks, as you know. So these two factors have really made the situation today where vehicles are increasingly large, increasingly heavy, and skewed towards pickup trucks and SUVs and away from cars. And this has consequences for affordability. So although this is a bit of a simplistic slide, the truth is embedded here. If one looks at the inflation rate in green, obviously it hasn't been a completely straight line over the last 30 years, but the gist of this is that it's increased significantly. So it's roughly 2.4 times as expensive as in 1990 for a basket of products. This is slightly below the IRS mileage rate, which I'm taking as a surrogate for affordability of the vehicle. So as you may know, the IRS puts a mileage rate for the appreciation of the vehicle, the insurance, the maintenance, the fuel costs. Doesn't include parking costs, which is a big deal in urban areas, but it includes other costs. And that has basically tracked quite well with inflation. Median household income, on the other hand, does not. So there is this increasing disparity between the cost of a new vehicle, and it's not just the initial purchase price of the vehicle, the cost to repair a vehicle has gone up as well, which is not included in this list directly. So vehicles are becoming increasingly unaffordable, with the consequence that vehicles are lasting longer. People are holding on to the vehicles longer. That's especially true for passenger cars. So these are some of the consequences that we see from increased vehicle costs. As I look at the future problems if we look at the trajectory of where the auto industry is going with electrification, autonomy, and connectivity, I believe that any solution at scale creates a new set of problems. And I remember 20 years ago, people were talking about how electric vehicles would solve a lot of environmental issues. And as we get more and more real about electric vehicles, we do realize that they create a new set of environmental issues as well. So when the internal combustion engine was first introduced on the roads, the internal combustion engine vehicle, it was supposed to be an improvement for the environment because people wouldn't have to walk through manure, horse manure, which can't have been fun, especially on a wet day. And so the internal combustion engine vehicle seemed like a very clean alternative. But as we know, at scale, it creates a lot of environmental issues, both in terms of air quality and energy security. So with the electric vehicles, as you well know, there's challenges with materials and security, both in terms of and this has also issues in terms of the environment and human rights when it comes to lithium and cobalt, and national security when it comes to rare earth metals. From a safety perspective, bigger vehicles are a problem. So the fatality rate per 100 million vehicle miles traveled hasn't been going down over the last few years as much as we would hope. And in fact, America is a little bit of an outlier compared to other developed world countries in terms of fatality rates. And if one looks at the weight of the vehicle, I think if you add 500 pounds to a car or an SUV and a pickup truck, it makes a big difference to overall road safety. So in all cases, making the vehicle heavier will protect the occupant more. Although in the case of a pickup truck, it doesn't make that much of a difference because the pickup truck is already very heavy. But in case of other road users and even people in cars for that matter, it makes a big difference. So you can see that the addition of 500 pounds to a car and a pickup truck makes the overall road safety worse. When you have a pickup truck colliding with a car, you get a net increase in deaths. And the picture on the bottom right basically shows if you're a pedestrian being hit by a tall pickup truck, you're far less likely to survive the incident than you might if you were being hit by a car at the same speed. And it's not just in terms of the mass, it's also the geography or the geometry of the vehicle making a big difference. So crash rates may go down in the future, but that doesn't necessarily mean that fatality rates will go down. Moving on to pros and cons of software-defined vehicles, which is another trend in the auto industry. So I've talked briefly about electric vehicles and the mass issue. Software-defined vehicles have certain advantages for the consumer, and obviously the automaker is very interested in developing these vehicles because it can create new monetization opportunities for the car company and recurring revenue streams. But there are some downsides to software-defined vehicles in terms of increased risk of security risks, and increased complexity, and even an uncertain business model. There's no real clear evidence to show that customers are willing to pay recurring revenue for updates or even apps, although the car makers are hoping that will be the case. And then loss of control of information. And this is a little bit extreme, but there's a trade-off here. You've got some nice benefits for the consumer on the left-hand side, but in my opinion, they're significantly dwarfed by some of the risks that can happen with software-defined vehicles. So I think there's a definite challenge with the commercialization of software-defined vehicles. In terms of autonomous vehicles, I'm going to address energy, safety, and congestion. I think from a safety perspective, the jury is out on whether autonomous vehicles are going to improve safety versus a well-equipped ADAS vehicle, which is not autonomous. I think there's a concern that ADAS does increase some confusion with the driver today, human machine confusion about how well it operates. We've seen that with like Tesla autopilot crashes. And if there's an increase in the VMT, which might well be the case with the introduction of AVs, that could lead to increased accidents, even if the rate of an accident per VMT stays constant. From an energy perspective, there are some advantages to autonomous vehicles, which I list on the green column, but I think they're going to be dwarfed by the energy consumed by the AV, both in the mines, in terms of digging the energy out of the ground, the batteries out of the ground, but because most of these AVs are electric, but also in terms of the cloud operation. The cloud consumes a significant amount of energy to make autonomous vehicles viable. There's a significant amount of training data and compute power, both in the vehicle and in the cloud, which I think is more than offsetting some of the benefits shown on the green column. But I think more importantly, we expect that AVs will induce demand for mobility. It will make it easier and more convenient to order goods, for example, and that will create more miles on the road for goods delivery. It will also create scenarios where you don't necessarily walk to your parked vehicle anymore. It comes to you, and it will lead to more demand for mobility, which I think will wipe out, from an energy perspective, the benefits of AVs. So I'm not a big believer that AVs will reduce the amount of energy consumed versus the conventional manually driven vehicle. And the same goes for congestion. I think the induced demand for mobility of robo-taxis in particular operate in the city center is going to make congestion worse, especially as you might have zero occupancy trips. So looking at the vehicle's environmental impact, I think it's very important to look at the mines and the cloud and not just the vehicle itself. And I think it's also very important to consider the history of human behavior, which is that we value convenience. And that means that we like the convenience that autonomous vehicles will provide, and that will drive more demand for energy and mobility. So I've raised a lot of potential unintended consequences of this future of autonomy, connectivity, and electrification. I've painted there's a bit of a dark side to some of the technologies, frankly, that are being developed, with some trade-offs, definitely. So I am proposing a different approach. It's not necessarily going to be a complete one-for-one replacement. It can coexist with the solutions that are being developed, and I think it will coexist. So please don't take this to mean 100% removal of the current trajectory. It's more of a use case, especially in urban centers, which is where the focus of my presentation will lie now. I think there's a real opportunity to rethink mobility, and that starts with looking at how the automotive product, the automobile, interacts with the city and with public transport. This is an example of poor urban design. This is a Houston city center. You see it's given up to parking of cars. And this is really driving the demand for more mobility, and making it harder for people to walk to places. So solving the energy challenge associated with automobility really starts with rethinking urban design, although that is a long-term improvement that needs to be made. But if one looks at cities, especially in Europe, this is Barcelona with their superblock design. They have a system whereby you really reduce the operation of cars in somewhat pedestrianized areas. It doesn't eliminate the cars. Emergency vehicles are still allowed entry into these regions. Delivery vans are allowed, and people who have cars inside are allowed to use them. But realistically, all of those types of vehicles I mentioned, the fleet vehicles and the residents-owned vehicles, can be expected to be pedestrian friendly in how they operate. They're not necessarily loose cannons like a regular car might be. So I think even though it may not be car free, it can be much safer and quieter for the pedestrians and cyclists to operate in these regions. In the cities that we're talking about in the future, there's a lot of emphasis being given to robo-taxis, especially in America and China. And this chart basically shows a comparison of robo-taxis, robo-shuttles, and robo-pods, which is a concept that I'm introducing in this presentation. So the robo-taxis are very well understood. They can operate on most urban roads, and they can pick up 5 to 7 people typically. And they may take jobs away from ride hailing and from taxis. They may add to congestion, reduce public transport ridership. So this is obviously a concern for cities that rely on public transport users. The robo shuttle works more effectively with the city. And so it's being looked at more seriously, I think, in Europe than it is here, where they have extensive public transport systems. But the robo shuttle typically operates on a fixed route and schedule, and it's kind of like a minibus, but it operates at low speeds in quasi-dedicated lanes, and there are some limited trials taking place. What I'm proposing is another solution, which is a robopod, which is effectively a small robotaxi, maybe a 2 to 4 person pod, which would be co-located or based at public transport stations and operate within a small operating domain centered on that public transport station. So if we look at London as an example, if you think about the suburbs, which is where people need connectivity with the public transport system, there may be like 6 different main transport hubs around the outskirts of the city. So in the city centre, you have extensive public transport system and there's congestion. So I don't think that is the right environment to operate robo-taxis. But in the suburbs, people need better access. Sometimes you may be 2 or 3 miles away from the nearest public transport station, and it might be raining, or you might have to carry heavy stuff, or you might even be disabled. So having a robopod that you can summon, like you do a robotaxi, that comes to you and allows you to access the public transport network, and then you can go all the way across the city using the public transport system, and at the other end you can take another robopod to go that last mile to where you actually need to go, would increase ridership on the public transport system and would provide people with much better accessibility to public transport than they have today in the suburbs. And these robopods would operate within a very small operating radius, maybe 5-mile radius of each of these transport hubs. So there would be complete coverage of the whole city. So this idea could be expanded to any city. I just use London as an example. So the pods could be charged at or near the public transport station when they're not being used, and that could be wireless or it could be manually charged. And the idea here is that the robotaxi companies like Waymo are developing not only the technology to allow the vehicles to operate autonomously, but because they are trying to develop the business as well, they're also developing the operations solutions that are needed, thinking about autonomous pickup and drop off, autonomous insurance, cleaning of the vehicles, refueling of the vehicles, maintenance of the vehicles. Basically, these are all of the skills and capabilities that are needed to operate a autonomous vehicle business as a fleet, and could make the subscription business or the rental
Let's
car
get past this
business
phase, and I
viable.
want to understand a little bit of this, our using a sequence.
Sorry.
Sorry, my bad.
Oh, okay. So the idea here is if you can summon a vehicle to come to your household or to wherever you happen to be, and it comes to you autonomously, and then you can drive it wherever you want manually because it still has a steering wheel in it. So you can still use it as a rental car and drive all the way across the country in principle. And then when you come back, instead of you going to the rental car agency to drop it off, it can go there automatically. You take away a lot of the friction out of renting a vehicle. And the idea in principle could be that you might not need as many vehicles per household. If you could make renting a vehicle very painless and easy for people and take all of the friction out, then it might encourage people to reduce the number of vehicles they need per household. And it may also reduce the need to buy an over-engineered vehicle. Instead of buying a large pickup truck that you hardly ever use, you might buy a small passenger car that you drive 90% of the time, and then you rent a pickup truck for the occasional time that you need it. And at the moment, that's a bit of a hassle to do that, which is why a lot of people don't do it and buy a big vehicle. So I think there is a certain, not everybody would do this, but I think a certain segment of the population might be interested in this because it would save them a lot of money and hassle in owning their car. So thinking about the vehicle design, I believe that solar power is going to emerge as a very attractive solution in the future for powering especially the small types of vehicles that I'm describing. And you're seeing car makers like Toyota, as well as startups, really embracing the technology, because solar power, just like battery technology, is improving significantly, and both in terms of cost and performance. This shows you that the dollars per peak watt produced is going to roughly halve between now and the end of the decade. And I think that gets to a point where it begins to be very attractive to put it on top of a roof or the hood of a car, and to generate electricity, especially in sunnier climates. So if one looks at this map of the world, in many parts of the world, between the tropics and even in places like Southwest USA, the size of a car roof panel, a solar panel, can generate over 5 kilowatt hours of energy per day. And that can be very significant if you have a vehicle like a golf cart or a tuk-tuk, because it could potentially allow the vehicle to drive about 50 miles per day on solar power alone. And obviously not every single day of the year do you have solar shining, but on many days you do. And on those days that you don't, you would plug it in like you would an electric vehicle. So this just shows you the different types of electric vehicles that might be used in an urban environment. If you look at the electric tuk-tuk or the electric quadricycle, which are becoming developed in India and Southeast Asia and in Europe, the efficiency of those vehicles is about 100 watt hours per mile. So a 5 kilowatt hour solar panel or solar generation per day would equate to a roughly 50 miles of range. And if you can charge the vehicle in about 10 minutes or so with rapid charging midway through the day, and maybe another time in the late afternoon, you could be having a vehicle that can drive 150 miles per day, which is very significant and could be very useful for a fleet operator for last mile goods delivery. If you look at a car or a pickup truck, even more so, a 5 kilowatt hour solar collection on the vehicle's roof might only generate about 10 miles of range per day, which might still be interesting, but it's not a game changer as it would be if you put it on an electric quadricycle or a tuk-tuk or a golf cart. So looking at some other parts of the world, in India, the two-wheelers dominate the market, as this chart shows, in terms of numbers of vehicles. So I did some volunteer work while I was at GM back in 2009, 2010 in rural Mali. And so I was doing this during some vacation time, and it caused me to be inspired to think about an electric powered vehicle, a solar electric powered vehicle that might be useful for the village. So I was working on the Shanghai World Expo at the time for General Motors, which was looking at the future of urban mobility for Shanghai and really advanced technologies like autonomy and connectivity and electrification. And at the same time, I was thinking about solutions for the poorest people in the world, where they don't even have access to electricity and would require a solar powered solution. And rather than thinking about a bespoke vehicle, because there may not be a single vehicle that meets all of their needs, I got to thinking about an aftermarket kit that could be attached or applied to a variety of non-motorized vehicles. So a non-motorized vehicle is basically anything that is pushed, pulled, or pedaled. And these include things like wheelbarrows or hand carts, tricycles. In the developed world, it might include wheelchairs, hospital beds, linen carts, meal carts, and so forth. But these are all vehicles that are non-motorized, where the addition of an electric e-kit that could be attached to it could provide extra utility, both in terms of a power-assisted mobility, but also in terms of as a source of electric power to charge cell phones or for pumping water, which is obviously a big concern in many parts of the world to get reliable water for agriculture. So I do believe that there is a sweet spot here in terms of cost versus utility, and recognizing that more than 1 billion people in the world don't have access to electricity, and that this could be a game changer that could be affordable enough. It could be a fleet-owned vehicle. They already have the non-motorized vehicle, but this e-kit would attach to it to provide power assist. And we built some prototypes that have been tested on farms. It's basically or the vision is that it would be the size of a briefcase. It would have different types of wheels and tires, depending on whether it's being used indoors, like in a hospital, or if it's being used outdoors, like on a farm. But the kit itself could be very common in terms of the power electronics, the battery, and the motors. And of course, the batteries could be reused, lithium-ion batteries from used electric cars. And we've demonstrated some prototypes. We even had the former Secretary of Energy, Granholm, reviewed it at FEV, where I was collaborating. And as I mentioned, we've tested it on different farms. So finally, I want to talk about vehicle manufacturing. So I do believe that if one looks at the low-speed types of urban vehicles, like the robopods, the electric tuk-tuks and quadricycles, there's an opportunity to rethink what the vehicle might be made of in terms of materials. Today's automobiles have a restricted choice of materials that can be used because they have such stringent performance and safety requirements. But when you relax those requirements, like you might in an urban environment that it perhaps could even be car-free, you can go with far more renewable and recyclable materials. And these are examples. 3D printed plastics is another example. It could be also made from recycled plastic bottles. Hyundai is developing a microfactory in Singapore that can produce up to 10,000 vehicles per year. So this concept of microfactories in the city creating vehicles is probably going to happen more and more in the future as we move towards electric vehicles and urban mobility. So there's a big difference between a greenfield auto factory complex, as shown on the left-hand side, and a downtown microfactory that could be in the city itself. The footprint, the number of people working there, the number of vehicles produced each year are very different in terms of scale. But this could be something that would be of interest, in my opinion, to cities in terms of creating jobs. And the vision here is that the input to the factory could be recycled batteries. It could be recycled plastics that would otherwise go into a landfill, or it could be agricultural waste, especially if one thinks about developing world. You have a lot of agricultural waste that's close to where the cities are located. And these could be input materials that go into making the vehicle, and then the vehicle would come out and be used locally to provide that last mile connectivity between the home and the public transport station. So there are several benefits to the city with local production of robopods. One is that if you can encourage people to use the public transport more because you make it easier to access the public transport stations in the suburbs, then you can reduce the subsidy per trip. There's economic development with the creation of a microfactory, and then there's waste reduction if you can tackle the waste going into the landfill. So cities are engines of innovation, although it might not be seen like that from an automaker's point of view, but they create constraints. Many cities, especially in Europe, but also in practically every continent, are increasingly putting in place charges and challenges to the use of a personally owned automobile. And this chart just shows you some examples of those types of restrictions. So cities, I think, have a big role to play in the future. This is The Hague, and it just shows you a car-free city centre, which is a paradise for cyclists and pedestrians, and doesn't seem to be hurting economic development in terms of the shops. So, as I mentioned before, if you can either remove cars from the city center or control the speed with which they operate, through GPS and maintain the vehicles at a sort of a 10-mile-per-hour top speed so that they don't cause harm to pedestrians or cyclists if they have a collision. Then you create the conditions to rethink what the automobile or the vehicle can look like. And you can dramatically reduce the performance and strength requirements and have a renaissance in terms of materials usage. You can make solar power become the dominant source of electricity for charging the vehicle, especially in summer in northern cities, but all year round in many parts of the world. And this would have other benefits in terms of allowing you to reduce the size of the battery and putting less strain on the charging infrastructure. And these vehicles are much easier to design and develop as well as make. So it could create good quality jobs locally that I think could make this attractive to certain politicians. I think there's an opportunity here for some cities, particularly in Europe, to stimulate the local economy as well as to make the city have a higher quality of life in the city center. And I think there's a role for the automakers. So I call it an ACE platform, autonomous connected electric platform, or skateboard, if you want to think of it that way. A car company may be making this type of platform anyway for their own vehicles, but if you think about it, they could supply that platform to a wide variety of cities around the world. They could license it, or they could actually manufacture it and supply it to those micro factories, so that the micro factories would then focus on the coach, the top half of the vehicle, which might be a lot easier technically than developing the whole vehicle itself. So this could be an auxiliary role for automakers that complements their existing business, because as you know, many car companies are struggling with rethinking their business model going forward and facing extreme competition from the Chinese automakers. So this could be an additional business stream for existing automakers. And it's a substantial business, because if one looks at the number of ride-hailing vehicles and taxis worldwide, it's a significant amount. It's about 30 million globally, and not all of them have to be replaced each year. Perhaps they have a 3-year life, so they need to be replaced every maybe 10 million vehicles per year. But that's a substantial fraction of the total number of vehicles sold each year, which is not nearly 90 million. So I do believe that there is a substantial addressable market here for urban vehicles that move both people and goods, especially since urban delivery or last mile delivery is expected to grow at a much faster rate than the automobile market is. And I think that this could be an opportunity for automakers, instead of feeling threatened by this, because at the moment they don't really sell too many vehicles to people who live in the city center, because a lot of people in the city center don't even own a vehicle, because it's not practical for cost reasons and convenience reasons, parking. So this could be incremental business. So in summary, I've tried to make the case that automobiles are becoming increasingly big, heavy, and powerful, and they're becoming more and more unaffordable to purchase, insure, and repair. And they're becoming less safe to other road users, whether that's pedestrians, cyclists, or even people in other vehicles. And that we need a different solution. And I'm optimistic that the technology and the operations capabilities that are being developed to solve the robotaxi challenge and to make it a viable business can be applied to actually make automobiles more sustainable and mobility more affordable. Making automobiles more sustainable because they could be right-sized, and making mobility more affordable because it could provide last-mile accessibility for people who can't afford a car. The low-speed urban mobility opportunity, I think, creates an opportunity to use locally made materials and to actually locally produce vehicles to create good quality jobs, and allows the community to be more and more self-sufficient, because they don't rely so much on electric utilities, automakers, big tech companies, governments, and so forth. They can be more self-sufficient and have greater autonomy. And I think cities have a role to play in supporting this transition, either with car-free or car speed controlled city centers. especially if they place a value on public transport use and the value of waste reduction and job creation. And I do think that automakers can support this transition. They don't have to be threatened by it necessarily, by licensing their platform to many cities. If you aggregate all the cities around the world, there's a lot of business to be spread around the automakers in terms of an ACE platform. So these ideas and more are included in my book that's just come out, that was published by SAE last month. It's called Sustainable and Affordable Mobility for All, Putting the Heart Back into Technology. And it's available on Amazon and Barnes & Noble, as well as the SAE website. And I just want to finish with a caveat here, that we're not good at predicting the implications of future technology. If we were told in 1990 that within a generation we'd be able to video chat with anybody anywhere in the world for free, and that we'd have this great source of knowledge called the internet in our hands, we would have thought that the future was a nirvana, perfect future. But what did we get? Well, we got some of that, but we also got this. And so I just want to make a caveat that none of us are really particularly good at predicting the future or the implications of future technology. So we need to stay humble in that regard. So with that, I'll wrap up.
Well, thank you, Chris. Assume you're getting virtual applause. While people are putting their questions and comments into the chat, which Jamie will start going through shortly, I always take my privilege as the chair to ask the first question.
Yes, please.
So, you made the comment, and we've talked about this 10, 20 years ago, that once we get easy rental car delivery to me, right? So the 2 times a year, I need a large SUV because I'm taking my kids to college. I no longer need that full-size SUV as my standard car. And so you've concentrated a bit on the city, but if I think of the 2 or maybe 4 passengers, A, B size car, that's your robo-taxi. Why isn't that also my personal mobility if I live in the suburbs, right? And then I get low cost, I get economy of scale. So how does that fit into the equation where that small robo-taxi I happen to own it? And because I live in a suburb, I have the place to park it.
But it's still a larger vehicle than you need for most of your daily use. For most of your daily use, you're just using a very small car to go from A to B. And when you want to go long distances, you need the steering wheel. I'm not predicting level 5 autonomy anytime soon. I'm assuming that the autonomous capability is good for local small operating domain driving. But if you want to go cross country like you might with a rental car, or go up north or what have you, you still would drive it manually. So the scenario I'm painting is that the vehicle can come to you autonomously from the nearest rental car or dealership, which might be a distance of a few miles. But then once you get it, you could drive it wherever you want, like you can any rental car today. And then when you finish with it, instead of having to go back to the rental car and sign paperwork and so forth, which is a hassle, and then find your own transport back to your house, it would go autonomously back to that place. So it would make it so much more convenient for you than today. And it wouldn't just be about the autonomous pickup and drop off. It's all about the maintenance and the cleaning and the insurance, taking all the friction out of that process, which is what the fleet management companies are trying to do for autonomous capability.
Yeah.
So that's one solution.
We can take this offline, but I think I would want to own it. Right.
I'm not saying that this is a one or the other. I think that there's a certain population that would find this attractive. I'm not saying it's a solution for everybody. There are obviously lots of people who like to have a big vehicle, even though they know that it's not logical to have a big vehicle all the time. They just like it, and I won't be able to change their minds. But there are other people who could have their minds changed.
Chris, so we can get to the comments, let me make clear what I was saying. My personal owned car, I want to be a 2-seat pod.
Okay.
I'm getting rid
Yes.
of the SUV in my
Yes.
garage.
Yes. Yes. And if you can't afford a vehicle at all, which 90% of the world's population can't, this would allow you access to the public transport system instead of having to walk 2 or 3 miles. So that's why I'm trying to solve both this affordability for the poor people and the sustainability for the rich people.
Great. So I'll let Jamie take over on the chat questions now.
Yeah, Chris, Serini says, great presentation, and has a question around the microfactory. Any insights as to why they haven't worked out so far?
Yeah, the economics have been challenging, I must say, for the microfactory in terms of the materials and also having to design vehicles that meet all the crash requirements is a big challenge for a microfactory because you have a lot of sunk cost in developing that capability. My argument here is that if you take away those constraints of crash capability and performance requirements, you don't have to operate on highways, you don't have to meet crash requirements, then you basically make the challenge of developing the vehicle much easier. So I think this could be a big enabler for the microfactory. And then putting a value on the jobs being created, I think, is important, but also the landfill and as I mentioned in my slide, this if you can show that you're going to help improve accessibility to public transport and that will drive more usage of the public transport system, that could be very attractive to cities. And the cities have a role to play here, and they could provide subsidies or other incentives that would make this more viable.
Great. That's the only question. Oh, here's another question. Really enjoyed the presentation. Thanks. One question in my mind is, to what degree will the added weight of the solar panels on the vehicle erode the benefit of the energy production?
The added weight, well, these panels are becoming, they're not the rigid panels that you might be thinking of. They're becoming increasingly flexible, and they can even follow the curvature of the roof. Now, obviously, for the low speed pods that we're talking about in the city center, the vehicles might have a completely flat roof, which would make it very easy. So the weight of these panels is probably around 20 pounds. It's not going to materially change the fuel economy of the vehicle or the energy efficiency of the vehicle, the actual weight of it, but it is going to make it so that you can obtain most of the energy required to propel the vehicle from from solar panels directly. I mean, even on a regular passenger car, Toyota has made claims that you can get 30, 40 miles range a day if the weather conditions are appropriate. Now, imagine what would happen if you made the vehicles substantially lighter. And you operated it in those climates where you have a lot of sun as a starting point. But even I would argue that even with the improvements being made in solar panels over the next 5 to 10 years, you're going to see more and more applications of this in vehicles, starting with sunnier climates first, and fleet vehicles that can benefit from this, because fleet vehicles tend to be localized. A regular passenger car can go anywhere, but a fleet vehicle that's operating in sunny climates would benefit from this tremendously.
Another question, in your opinion, where does aerial mobility, such as eVTOLs or other personal air transport solutions, fit in? Do you see it playing a meaningful role in the long term?
I do see it playing a meaningful role. I describe it in the book as well. I think that initially it's going to be seen more in terms of like the business passengers wanting to fly from the airport to the downtown center. You're going to see it for goods delivery. I mean, you're already seeing that in places like in Africa, where the roads are not very navigable in some places, and delivery of medicines and critical materials can be done more effectively and quicker with aerial vehicles like eVTOLs and drones. So I think it can complement public transport and complement mobility. I think the way to reduce congestion is in the city center is to think about nighttime operation for vehicles like fleet vehicles. that don't have to be operating necessarily during the day and can free up road space during the day, and they can operate at night. And that will require some changes in terms of business practices at night time, as well as regulatory changes from the city. And the other is to move vehicles to the different dimension. So moving vehicles to operate at night and moving vehicles to operate in the sky are both ways that we can help to reduce congestion during the day. So I do think it has a role to play. Yes. I think China is taking the lead in this area, as one might expect, with far more support from their national government than we're seeing here.
Here's another question about the e-kits. Are there applications for these within the factory floor or a company campus as a first use?
Yes, if you think about it, if it operates autonomously, it's not that different from a Roomba. And so I definitely see an opportunity for something like this in a factory. But the value proposition I'm proposing for the e-kit is that it can be universally applied to a variety of vehicles. It's not just a bespoke solution, because you can buy bespoke solutions today for hospital beds or for wheelchairs or for wheelbarrows. But trying to develop a kit that can be used for hospital beds, for gurneys, for wheelchairs in a healthcare environment, or for meal carts and linen carts, a kit that can be applied to all of these non-motorized vehicles in a healthcare environment, or a kit that can be applied to a tricycle that can deliver produce to market, as well as to a handcart or wheelbarrow that can move mulch around inside the farm itself. That's the power of the idea, is to have something that can be shared among different vehicles that all need that same utility, rather than having a bespoke solution for each individual vehicle.
I think that's the last question I see. Alan, do you want to mention the next third session and wrap us up?
I just have one more question, since I can. Chris, I think you were the one who showed me this graph many years ago, which showed that over the centuries, the amount of time people spend on mobility has not changed. Just the speed as we move from walking to animals to railroads to cars increased. You pointed out at the beginning a potential downside of, we'll call it the robo-taxi world. Do you actually think people will break that rule and spend more time moving? You only have 24 hours in a day, and I seem to recall it was about a 2-hour block for movement. Are you thinking that can change?
I think it can change if you can use the time productively, which we know we can with smartphones and wireless connectivity. Many people have said that they would be much happier taking a long road trip that lasts 10 hours in the car if they didn't have to actually physically drive. So that's a definite use case where it's going to increase the demand for mobility. People might not take the plane as much if they can drive a car themselves or ride in the car themselves. So I do think it's going to increase the amount of miles driven, not in that sense, but also I think it's going to allow people who can't drive to drive. Today, if you are not able to drive, you can't get into a vehicle by yourself and be mobile. That will change with autonomous mobility. So the amount of the induced demand for mobility, I think, will increase for that reason as well. Not necessarily that people will spend more time in the vehicle per day, although they might. But even if they don't, you're going to have this increased demand for mobility. And as we know, I was just in India, and people are calling Amazon and getting 10-minute delivery. I mean, 10-minute delivery is standard for food and kitchenware products in India, and it's incredible. But this induces demand for more mobility that wasn't possible in the past. And I think this is going to wipe out any incremental energy savings we might be able to argue on the vehicle itself. This human behavior, people value convenience. People are inherently lazy, in my opinion. So I think this is something we should all be aware of. And then I think the amount of energy consumed by the cloud, we focus a lot on the mines in terms of the mining of the materials for the EVs, but the cloud is a huge energy sucking force in terms of AV operation. And it's not just a one-time training and then it doesn't use it anymore. The autonomous operation will have to continually be improved over time to get to that level 5 capability. So this is going to be an ongoing burden in terms of the energy usage. And frankly speaking, I think the regulatory authorities need to think about energy far more broadly than the vehicle. They need to look at the cloud energy consumption per vehicle, as well as the mining of the materials. And from a safety perspective, they should not be focusing only on the occupant safety. They should be thinking of road safety as a whole, and ideas to improve road safety rather than just individual occupancy safety per vehicle.
Well, Chris, you never fail to deliver on a new challenge to the industry and to society, and you did it again. Thank you. For those of you who have not yet become an affiliate of the Electric Vehicle Center, if you go to our website, it's easy to just sign up, and it is no cost. Everybody is welcome, and it'll give you warnings about future of these seminars, as well as access to our monthly newsletter, etc. Talking about the seminars, our next Surge session is with Michael Maten from GM on EV policy, and he's even indicated he's willing to talk about tariffs and other regulations. So it should be a really challenging session. With that, again, I'd like to give Chris a round of virtual applause.
Thank you.
And looking forward to seeing everybody at the next Surge seminar.
Thank you very much.
Thank you. Chris, you want to stay on a second?